The universe is a vast, dark ocean. For most of history, we gazed up, wondering what lay beyond. Then, we built a new kind of eye, the James Webb Space Telescope, or JWST. This isn't just another telescope, it's humanity's boldest attempt to look back in time, to the dawn of creation. Its mission, to see the first stars and galaxies after the Big Bang. Unlike Hubble, which sees mostly visible and ultraviolet light, JWST is designed for infrared, letting it detect ancient, stretched light from the universe's earliest days. To do this, it traveled 1 million miles to a special spot in space, L2, and unfurled its golden mirrors and massive sunshield, a feat of engineering precision. The sunshield keeps its instruments cold, so it can spot faint heat signals from distant galaxies. JWST is a testament to human curiosity and ingenuity. On October 5, 2025, this powerful eye opened and revealed something no one expected. Not just another distant galaxy, but something that didn't fit any model. It challenged our understanding of the cosmos. The telescope was built to answer old questions, but its greatest gift may be the new mysteries it uncovers. What it found sent ripples through the scientific community. The universe, it turns out, is even stranger and more wonderful than we imagined. With JWST, we're not just looking for answers, we're discovering new questions. And sometimes those questions change everything. The discovery began quietly, as most do. JWST was surveying a patch of sky in Fornax, searching for the faintest, most distant galaxies. Weeks of data poured in, light that had traveled over 13 billion years. Amid the data, a junior astronomer noticed a persistent, tiny point of light. At first, it seemed like a glitch, but it appeared in multiple exposures. This was no artifact. It was real, farther away than almost anything ever seen. In a region where the early universe should be crowded, this object stood alone. Its isolation was the first clue, something truly out of the ordinary. The team logged its coordinates and gave it a provisional name, JDF-AZO-1, but soon it earned a nickname, Ethel, meaning noble or strange. In the cosmic dawn, where chaos reigned, Ethel was a solitary, perfect beacon. It was a skyscraper in a desert of sand. The team knew they had found something extraordinary. When Ethel's first image appeared on the control room screen, the room fell silent. Years of work, billions of dollars, and thousands of minds had led to this moment. Against a backdrop of ancient galaxies, Ethel wasn't a smudge or a faint blob. It was sharp, distinct, and utterly bizarre. Dr. Eris Thorne, the team leader, had seen countless cosmic wonders, but never anything like this. It defied categorization. Not a spiral, not an elliptical, not a quasar. Just something new. The thrill of discovery was electric, but so was the confusion. Science thrives on patterns, but Ethel shattered every model. The team realized they were witnessing a pivotal moment in astronomy. They had expected to find the familiar, but instead, they found the unimaginable. Ethel was a cosmic curveball. The initial joy quickly gave way to intense questioning. What were they looking at? Every known type of celestial object was ruled out. The image on the screen was a mystery, one that would change everything. The universe had just become a lot more interesting. So, what did Ethel look like? The JWST revealed a perfectly symmetrical, six-pointed structure, like two pyramids joined at their bases, forming a diamond. It was massive, several times the size of the Milky Way. Such perfect geometry shouldn't exist in nature. Gravity shapes stars and galaxies into spheres or disks, not polyhedra. The spectrum was even stranger, no hydrogen or helium lines, just a smooth, pulsing infrared glow. The light came from within, a cool blue-white, not from stars on its surface. Ethel rotated in a complex repeating pattern, not on a single axis, but tumbling with precise regularity, 77.3 hours per cycle. This level of order and isolation was unheard of. Most baffling, its age. The light was over 13 billion years old, from a time when the universe was still primitive. Finding such complexity so early was like discovering a smartphone in the age of dinosaurs. Ethel was more evolved than its surroundings, a paradox of light and mystery. It didn't fit any natural explanation. It was a cosmic enigma. The days after the discovery were a blur of frantic activity. Dr. Thorne placed a strict embargo on the data. This was no ordinary find. Teams checked for instrument errors, glitches, or lensing effects. Every system was nominal. The data was real. Theorists filled whiteboards with equations, searching for any natural explanation. Could gravitational lensing create such symmetry? The odds were astronomically low. Exotic ideas, crystal stars, gravitational solitons, were considered, but nothing fit. Late-night conversations drifted to the unspoken question: could this be artificial? The idea was thrilling and unsettling. For scientists trained to seek natural explanations, Ethel was a challenge to everything they knew. The possibility of intelligence behind it hung in the air. As errors were ruled out, the team faced three main theories. First, Ethel might be a new, bizarre natural object, perhaps a crystalline structure formed from exotic matter. Second, it could be a projection from a higher dimension, a glimpse of another reality intersecting ours. These ideas stretched the limits of known physics. The third, most controversial. Ethel was artificial, a megastructure built by an ancient civilization. Its size, symmetry, and complexity pointed in that direction. Could it be a beacon, a habitat, or an energy collector? The idea was staggering: intelligence at the dawn of the universe. Even if unproven, the possibility changed the conversation. The search for answers had entered uncharted territory. News of Ethel's discovery sent shockwaves far beyond astronomy. It was a paradigm shift, forcing us to rethink our place in the cosmos. The existence of such a structure so early meant our models of galaxy formation were incomplete. Cosmologists and astrobiologists scrambled to explain how such order could arise so soon. If Ethel was artificial, it suggested intelligence is ancient and widespread. Even if natural, it proved the universe can create complexity we never imagined. The line between natural and artificial blurred. The discovery reignited curiosity and wonder, both in science and the public. The greatest discoveries, it turns out, are those that reveal how much we still don't know. Ethel had changed our cosmic story forever. The discovery of Ethel is just the beginning. JWST will now focus on gathering more data, deeper images, detailed spectra, and environmental clues. Scientists will look for changes, gravitational effects, or hidden energy fields. The next generation of telescopes will be designed with mysteries like Ethel in mind. The search for answers will shape the future of space exploration. Whether natural or artificial, Ethel forces us to rewrite what we know. It may take years to unravel its secrets. But the door is open, and humanity is peering into a new cosmic room. The universe isn't done surprising us. The next chapter awaits.